The position function of a particle moving along a horizontal line is given by this function. That's the position function at any time t. Find the velocity and acceleration functions. So when we find the rate of change of position, that means first derivative, that's velocity, and rate of change of velocity, that means another derivative, is acceleration. So let's answer A. That should be pretty simple. So the velocity, let's denote by v as a function of t, is derivative of this with respect to t. Find the derivatives. That's 3 times 2, 6 t squared minus 6t minus 12 plus 0. No need to write, that's the velocity. And acceleration, let's denote by at. That's the derivative of this velocity, or derivative of this. So derivative of this is 12t minus 6. Okay, that's part A. Let's move to part B. At what times is the particle at rest? Okay, the velocity gives us the direction, in which direction the particle is moving. Velocity positive means the particle is considered moving right. Velocity negative means considered moving left. That's the convention. And that means velocity 0 means the particle is at the rest. So to find the time when the particle is at rest, we simply set the velocity 0 and solve for t. Okay, that means this 6t squared minus 6t minus 12 equals 0. Now solve for t. So this is degree 2 trinomial function. So here trinomial, so we need to factor the left side. If it does not factor, then we must use the quadratic formula, or we can complete the square. But it looks like it factors 6, 6, 12. Let's take 6 out first, out of all three. T squared minus t minus 2. Okay, 6. We can factor this trinomial as a product of two binomials. So t squared, t times t. 2 means 2 times 1, 2. And to get negative in the middle, that goes in the bigger plus. If we FOIL, if we multiply t minus 2 and t plus 1, we get this. Okay, that means we can divide both sides by 6. So 6 has no contribution in finding t. So t minus 2 equals 0, or t plus 1 equals 0. From this, t minus 2 is 0 when t equals 2. And t plus 1 is 0 when t equals negative 1. So we got 2 times 2 and negative 1. But time is measured always positive, so we need to disregard that. So for part B, at what times the particle is rest, just t equals 2. So at t equals 2, and we can write seconds. Okay, let's do C. On what time intervals is the particle moving to the right or left? Okay, so we need to test the sign, okay, whether it's positive or negative of velocity. So this is the velocity function. So let's make a domain. So time starts, this is time, at 0, and is going forever, because we don't have any limits given in the question. And we know that the particle comes to rest at t equals 2 seconds. So we need to consider t equals 2. Now we test the sign of velocity in these two intervals. So we need to pick a representative in between 0 and 2 and plug in here. Same thing, 2 to all the way. This is all the way. Pick one representative and plug in v. Okay, we can pick t equals 1. We can pick t equals 3. Okay, you don't have to write this. So plug in 1 here. If we plug in 1, this is 6 minus 6. 6 minus 6, 0 minus 12. So velocity is negative. If we plug in 3, 3 squared 9 times 6. Okay, it's going to be positive. That means the particle is moving left here because the velocity is negative, and moving to the right direction in here. So the particle moving left on 0, 2 and moving right on 2, 2 all the way, infinity. Now part D, determine the time intervals when the particle is speeding up or slowing down. Okay, speeding up or slowing down means we need to test the signs of velocity and acceleration, both velocity and acceleration in this time interval. So we have this domain 0 through all the way, and we know the velocity is 0 at 2, so let's include that. We need to take acceleration into account as well. And acceleration, if we look at here, acceleration is given here, right? Now we need to determine where this acceleration is 0. So 12t minus 6 equals 0. Subtract, add 6 both sides. So 6 over 12, 1/2. So we need to consider 1/2 as well. So somewhere here. Okay, so we need to check the signs of velocity and acceleration in these 3 intervals, by the way, 0 to 1/2, 1/2 to 2, and 2 to all the way. We already know the sign of velocity, so let me record that so don't have to work again. So 0 to 2 is negative, that means it's negative here, it's negative here. Okay, then after 2 is positive. Okay, 0 to 2 negative, 2 to all the way positive, so I just wrote that. But we need to consider one more interval because of acceleration. Now let's check the sign of acceleration, at. And we know that the acceleration is 0 at 1/2, so we need to test here and all the way. On the right of 1/2, it will have only one type of sign, and on the left of 1/2, it will have one type of sign because the acceleration is 0 at t equals 1/2. So let me take on the right side bigger than 1/2, maybe 1 somewhere here, 1. Plug that into acceleration. Okay, plug 1 here. Okay, t equals 1. If we plug in t equals 1, it's going to be 12 times 1, 12 minus 6 is positive. So 1 is here, so positive. So acceleration is positive here. And if we test here, it's going to be positive here too. Because acceleration is 0 at 1/2, and it's going to be positive for the rest of the interval. On the left, we can try with 1/4, which is less than 1/2, 0, 1/4. 12 times 1/4 is 3. 3 minus 6 is negative, so it's going to be negative here. Okay, and whenever velocity and acceleration have the same sign, that means speeding up. When they have different signs, that means slowing down. So here, negative, negative here, 0 to 1/2, and plus, plus here, 2 to all the way, they have the same sign, means speeding up. So speeding up on 0 to 1/2 and 2 to all the way. And then slowing down here, 1/2 to 2. Final.